Hello folks, welcome to today's video. In today's video we are going to be looking at transformations. So the first type of transformation we're going to look at is reflections and the line of symmetry. So the word symmetry, you may have heard it before, but to be symmetrical is to look the same on both sides. And there's all kinds of examples of symmetry in our day-to-day lives, right? Humans are just naturally attracted to symmetry. We find things symmetrical to look beautiful. So anytime you have a company that's designing something for people to look at, they're going to design it with symmetry in mind, right? But we also see symmetry in other aspects of the world, not just designed things like reflections, our own reflection in the mirror. Human bodies are symmetrical, right? Two hands on either side, two legs on either side, right? Cut the face in half and you get two eyes, and everything is always, not everything, but a lot of things in our day-to-day lives are symmetrical. So a line of symmetry. A line of symmetry is a line that takes an object and cuts it in half, so that both halves are mirrored images of each other. So if you just imagine, for example, if you took, say, like a mirror, and you put a mirror right on your face, right, and someone were to look at that mirror in a certain angle, it would almost look like it was your whole face, where your left side of your face would just be the reflection in that mirror. Maybe you've seen these like experiments before, where if you stand by a mirror, so that way half of your body is on the mirror, and then you start lifting your legs, it looks like the other leg is lifting as well. Same idea, right? We're just thinking about this line of symmetry as being a mirror. So when it comes to shapes, what we look for is what part of my shape is a reflected image of the other, right? So for example, in a rectangle, right, if I were to cut my rectangle in half, right, the left-hand side and the right-hand side are reflections of each other, right? If I were to cut my rectangle in half the other way, the top and the bottom would be reflections. If I were to look at a square, there's a few more reflections because of the natural symmetry of a square, because all four sides being equal, right? So we see that there, depending on the shape, we can have different numbers of lines of symmetry. So here's just a couple examples, right? So if I wanted to take these shapes here and cut them in half, so that way they were reflections of one another, the two halves were reflections, right? So for example, for this arrow, its line of symmetry would be a line that cuts it right down the middle, because the top would be a reflection of the bottom. For this oval shape here, we'd have a line of symmetry that cuts it in half down the middle, top to bottom, and it would also cut it in half down the middle, left to right, right? So we'd have two lines of symmetry. Now, when I'm talking about a circle, something interesting happens. So I could have a line of symmetry there, or I could have a line of symmetry there, I could have one here, I could have one there, and I could actually keep going with a circle, because a circle actually has an infinite number of lines of symmetry, because it is perfectly symmetrical. No matter how you draw that diameter, it's going to be a line of symmetry. Okay, so for this image down here, we have a 4x4 square. So again, we have a couple of lines of symmetry. We have a horizontal one and a vertical one, but we also have these diagonals as well. Okay. For this triangle, it's hard to say whether there are lines of symmetry or not. Sometimes our eyes can be a little deceiving. Now, if this is an equilateral triangle, meaning that all three sides are the same, in that case, I would have three lines of symmetry, one through each corner, and there we go. Okay, so there's all kinds of these lines of symmetry that we could be looking for depending on the shape. But the other half of this is what happens when you're given the line of symmetry. So when I'm given the line of symmetry and I'm asked to find the reflection, the way that I like to do this is I like to break up my points into vertical and horizontal components. And what I mean by that is we would describe this blue line as being a line of symmetry at x equals 6. Okay, because in math, when we're talking about these grids, they are x and y axis. So this vertical axis is the y axis, this horizontal axis is the x. So because we have this line that passes through our x-axis at 6, we'd say that the line is described by x equals 6. Then what I'm doing is I'm finding all of my distances. How far is point A from this line? So if I look at A, it's 1, 2, 3, 4 steps to the left. So its reflection is going to be 1, 2, 3, 4 steps to the right. and I'm going to label this point A prime to indicate that it is the reflection of A. And if I do the same thing for B, so it's 1, 2, and a half, so 1, 2, and a half, and there's my B prime. Now what you'll notice is that C and D are actually both right on my axis of symmetry, so they are 0 distance away, so its reflection will also be 0 distance away. So now if I connect my points here, I have my reflected image. Okay? And then I could do the same thing on this axis of symmetry as well. Now this one, because it's a horizontal line that passes through my y-axis at 6, we would say that this is y equals 6. And again, what we're going to do is find the vertical distances that this line is from each of my points. So again, point A is 1, 2, 3, 4 down. So its reflection will be 1, 2, 3, 4 up. Point B, I guess, is 1, 2 down. So point B's reflection will be 1, 2 up. Right? So there's A prime, there's B prime, and then C is also 1, 2 steps down, so it'll be 1, 2 steps up. And then D is 1, 2, 3, 4, so it'll be 4 steps up, and I have my D prime. So there's my reflection, A, B, C, D. Okay? So it's really important that we are looking at the horizontal and vertical components, because that's how we're going to find these reflections the easiest way possible. So let's try one more example. So for example, if I didn't give you the graph, if I didn't say here is my graph, instead I said here are the points that make up that image, and I want to reflect those points. So write the coordinates of the new shape after reflection in the horizontal line through the y-axis at 2. So what that means is if I had my xy grid here at y equals 2, that's where my horizontal line is. And again, what we're going to do is we're going to figure out what is the distance from that line to these points in order to find their reflection. Now, the way that we read a point is x comma y, where the y number is the second one. So for example, this point here is at 2, 2, meaning that starting from the middle of my axis, I would go to the right 2 and I would go up 2, right? And what we'd find is that because the y value here is 2, it's actually right on my axis of symmetry, so its image or its reflection is also going to be at 2, 2. Now for point B, we have a value of 2, 5. So again, what we look for is the distance. How far away is 5 from 2? Well, it's 3 units above, so its reflection is going to be 3 units below, or in other words, 2 take away 3, which is -1. And the x values won't change because we're reflecting about the y, right? Just that vertical distance, so 2, comma, -1. Okay, x value won't change. So again, 6 is 4 units above 2, so we would go 4 units below 2 to find its reflection. And again, 2 is right on the axis of symmetry, so our last point is also going to be at 2. And there are the coordinates of my new point. Okay, so that's it for today. So when we're talking about reflecting and symmetry, we're talking about the distances it is away from those lines. So if I have a horizontal line of symmetry, we're talking about vertical distances. And if I have a vertical line of symmetry, we're talking about horizontal distances. And again, vertical distances have to do with the y values being the second point in an ordered pair, and the horizontal distances having to do with the x values, and the x values being the first point in our ordered pair. All right, so that is it for today's video, and I will see you all in the next one.